Okay, it's my pleasure to introduce Dr. Beth Willman to NCSA and for our CAP seminar. Beth received her PhD in 2003 from the University of Washington. She worked on the early days of the Sloan Digital Sky Survey. She discovered a population of ultra-dwarf galaxies that some were named after her. More than one or just the one? Just one. She had a number of fancy fellowships, eventually became faculty at Haverford, was chair of the department, and then left to join the LSST project as deputy project manager, deputy director, and then had a few more roles at NOR Labs. Recently, about a year ago, became CEO of the LSST Corporation. And just in the scheme of things of how this works, the corporation, they were the kind of the ones that received private foundation money. So they got the money from, I'm blanking on the guy's name. Simone and Bill Gates to build the primary mirror. That was like 30 million-ish. And now they're going to be, like in the future, they're going to be kind of the science arm of the project and the interface between the community and the project. So without further ado, Dr. Beth Willman.
Excellent. Thank you so much. So I'm a wanderer. If there's any issues hearing me on Zoom, I'll look through the window there, and hopefully that's being monitored as well. Perfect, I got a thumbs up. Thank you all so much for taking the time to come to the talk today. I know there's free pizza, and I also know that you'll be finished with your pizza before I'm finished talking, so thank you for the extra time and attention. And thanks to those of you who I've already had the chance to get to know a little bit and meet. I had a really good time in the conversations I had with some old colleagues, especially with the students yesterday, and then also at the Astronomy on Tap event, which was super fun. So I'm here to talk about, I'm really into the word ecosystem, I'll try not to overuse it, the Rubin LSST Ecosystem today. And I know that's a very jargony title, which isn't very welcoming, but I'm really glad to see a lot of you still came to hear me out. So I'm going to start with explaining briefly what do I even mean when I say Rubin LSST, and then we'll go through the ecosystem, and I'll talk specifically in the second half of the talk about what it is that private nonprofit organizations even doing for the scientific community, and what are some ways that NCSA and Illinois are already involved, and what are some possible ways that we can strengthen our relationship in the future to help really amplify stuff that's already going on at NCSA. And I've had some fun brainstorming conversations about that already during my visit. So Rubin LSST is the Vera C. Rubin Observatory's Legacy Survey of Space and Time. And so this was the title of my public talk yesterday. The acronym for Legacy Survey of Space and Time is LSST. Back in about 2003, when LSST Corporation was first incorporated, and that $30 million donation came in from Bill Gates and Charles Simone, the acronym LSST stood for something completely different. It stood for the Large Synoptic Survey Telescope, which isn't, a lot of big projects have a working name, but then as you get closer and closer to operations, the name is updated to something more engaging and that resonates more with the spirit and the goals of the project. And so that's where Vera C. Rubin's name comes in. She's renowned astrophysicist and is widely credited with having made the first concrete evidence discovery of dark matter in spiral galaxies in the 1970s. She was a pioneer for the role that women could play in astronomy, and in fact was the first woman to legally observe at a US observatory, and that was Lick Observatory. Those were the observations that she used to discover dark matter. And just a magnificent individual, really breaking down barriers, and widely known as not just being a leading scientist, but also a committed mentor to her students to make the future generation. So the start of the survey I'll be talking about is planned to be in early 2025, calendar 2025. I started working with LSST as a member of the scientific community, a science collaboration, back in about maybe 2008, so about 15 years now. And at the time the survey was supposed to begin, I don't know, probably 2018. And that's pretty typical for these major projects that are billion-dollar scale over time. Expected dates get pushed out, and of course the pandemic has disrupted many aspects of our lives, and it certainly had a major disruptive impact on projects like this. And in fact, the delay often exceeds the length of time that the pandemic has been going on because of lasting impact on things like supply chain and on availability of people to do the things you need to do to move the stuff to the observatory to get it up and running. Okay, so fine, we've got Rubin Observatory's LSST, but what does that mean? It's what you get when you put an optical camera with 6 broadband filters, UG-RIZ-Y bands, not the same as DES, but similar, on an 8-meter telescope with a field of view the size of 40 full moons, and then use that camera to take 1,000 images of every part of the sky visible from that location on Earth over a 10-year period. And so the location on Earth is in Chile, outside of La Serena. It's on a very well-developed pair of mountaintops, Cerro Chololo and Cerro Pachón. A number of you have visited there to conduct observations and are familiar with the CTIO 4-meter telescope. That's where the Dark Energy Survey was conducted. The 8-meter Gemini South telescope is on Cerro Pachón as well. SOAR, a 4-meter telescope, also on Cerro Pachón, and that's where Rubin LSST is being constructed as well. So it makes a lot of sense, right, when astronomers look and try to pick where they're going to put the next big thing. You take a look at image quality. What are the conditions like for observing? And then also, what infrastructure is available to make it feasible for a not insane cost for me to build and robustly sustain a construction and then operations project? So I'm going to show just a few slides that I shared last night to make sure everybody has the same kind of baseline information about what are we talking about, what is Rubin LSST. So the camera that's conducting this survey is the largest digital camera in the world with a 5.5 foot lens. The size is often compared to VW Beetle, like a small car, a bit bigger than a smart car. People really like the corgi thing, so I'm showing it again. And another analogy is that you can fit, this is an outline of the camera, maybe like about is there 100 corgis in that picture? Maybe about 100 corgis inside of the camera. And if you're not familiar with that type of a stout dog, it maybe they're like 30 pounds. You can fit one in your mailbox, and the head would stick out. And this image has gotten a lot of use over the last approximately 10 years when Margot Lopez, an engineer at Slack, first put it together. But I've been seeing a lot of corgi references this week in astronomy social media. Anyway, I'll stop on the corgis for now. So I said this camera, this world's largest digital camera, is 3.2 billion pixels. The dark energy camera is about 500 million pixels for a sense of like relative scale. The DE cam, Hyperspeed Prime cam, they're sort of reasonable analogs, but still about a factor of 10 less in size. There's less étendue of the system, which is sort of how efficiently you can make a map of the sky with those cameras, but still remarkable scientific discoveries and lessons can be learned that can be applied forward to LSST. And so then when you think about like trying to really make concrete how much of the sky is this camera taking with every picture, your thumbnail held at arm's length is about the size of a full moon. And so if you hold it up and hold it in front of the full moon, it'll about cover it. So it's about 50 of your thumbnails held out at arm's length is a single snapshot. And so one thing I want to communicate, also because it connects so much with a number of the research innovation areas here at NCSA, is a sense of that scale, volume, and velocity of the data. There will be 20 terabytes taken per night with 50 petabyte total size at the end of the survey. Is there an audio issue? Is it okay? It's like a little echoey. Okay. And the velocity is very high, so at each location of the sky there'll be 2 snapshots stitched together for one picture, and 2 seconds of readout for the 3 billion pixels, which is insane. the slew time is very short for this telescope, so about every 40 seconds there'll be another observation made. That data will come off the mountain, come up to the United States, get processed at SLAC, and immediately alerts for where the sky has changed since the last time that parcel of the sky was observed will be released to the worldwide community with no data access limitations. And so there's two components to this magnificent map. It is the real-time component with the alerts of how the sky is changing, as well as the static sky observation, where over time there'll be an increasingly sensitive map of how half of the sky looks to a greater depth than previously observed for such a massive optical survey. So each red circle shows, again, that roughly 40 full moon equivalents, what it would look like on a picture of the night sky, put behind an image of what, I forget which telescope this is. Anyway, it's not Rubin LSST. Every single one of those pictures that's coming off the telescope every half minute will have 10 million galaxies inside that single image. And so this is the rate at which the data will be coming off the telescope to the scientific community. And I had my scientific coming of age with the Sloan Digital Sky Survey. And I could sit at my old, I don't even know what type of computer it was. I could download like the entire 10 million star catalog, and I could write some incredibly poorly written IDL code and process it right there on my desktop again and again and again. And maybe if I was doing something really crazy, it would take overnight, right? And so we're just in a completely different era of data analysis, which again, surveys like DES have helped pave the way for in optical infrared space. In order to see a single image in full resolution, if you're thinking about like regular HD TVs, or you could be thinking about like the new generation, 8K, like OLEDs, it's about a quarter of a basketball court for the newest generation of highest resolution TVs to observe it in full resolution. Similar size is like 2 full billboards worth just to see a single observation in full resolution. The pixel size, 0.2 arc seconds per pixel, smaller but not so much smaller than DES. DES about 0.27, I think, arc seconds per pixel. So at the end of survey, 40 billion objects, stars and galaxies will be cataloged, more than humans on Earth. And in a typical image of the sky, and here's an image from the Deep Lens survey, and the size of this image is, if I remember, maybe 1/40th of the size of a typical Rubin LSST image. The depth, how sensitive it is to see very faint, very distant objects, is comparable to, but about 1/2 as sensitive as the full final LSST observation. And in a typical image that's looking away from the milky plane of the galaxy, the vast majority of dots in this image are galaxies. Right, you see these saturated red points that are stars in the Milky Way between us and other galaxies. And I'll zoom in, it'll be somewhat low resolution, but you'll get the picture. So this is about 1/10 of that image I just showed you. And you can see some galaxies are large and near enough that there's some structure to them. You can almost tell even though it's a bit low resolution. But all these teensy little dots, they're distant galaxies that are so far away that they look like points of light. And so one challenge for people like me, I tend to study galaxies that are so close that you see them granular. They're resolved into their individual stars. And so a challenge that has been considered by people like me in my scientific community for the last 10 years is you can't tell a star that's faint from a galaxy based on the way it looks, because the vast majority of very, very faint dots in your image are unresolved galaxies. And so, of course, there's a lot of different ways you can try to get around this and mitigate this galaxy contamination, and it keeps it fun. Okay, so this survey strategy was designed, one instrument, monolithic survey strategy, half of the sky. It was designed, and the requirements of the detector detectors and of the camera, the engineering requirements were designed so that this single monolithic survey could revolutionize questions from the solar system, how did our solar system formed, what are all of the potentially hazardous asteroids that could potentially impact Earth in the coming years, to understanding more about the galaxy that we live in, to distant galaxies, to dark matter, to dark energy. So the Department of Energy funds the study of dark energy, and so they're a partner with National Science Foundation in running this experiment. As well as, of course, the transient variable universe, which is a focus of a number of people at Illinois. How does the sky change with time? What can that teach us about where the elements came from? What are different types of explosive events? And even, can we observe explosive events that we can predict would have led to mass extinction in other places? And I've called out a first-year graduate student's research on that twice because it sounds really cool, and it is really cool. So this construction project has been going on since about 2015, even though this project timeline that's updated roughly every month on the LSST website. It's been going on since 2015, even though the actual work to get here has been going on since 2002, 2003. I talked to Joe Taylor yesterday, who was reminiscing about a talk here, I think 2001, 2002, when the initially known as the Dark Matter Telescope was just starting to become known as the Large Synoptic Survey Telescope. Again, fantasizing about what could be, and we're finally there. So the forecasted finish here, and that's a calendar year, end of calendar 2024, so about a year and a half from now, is when first light with that enormous camera is expected to be on the summit. Now that enormous camera was built at SLAC with DOE money. It's still in California. Of course, if you're, a $150 million camera, you get your own chartered airplane when you go down to Chile, and so that's a next step in getting closer to really being certain about when the dates are and when the survey start date will be, which, as I said in one of the first slides, currently predicted to be in early 2025. One thing that I spoke about to students yesterday in our roundtable meeting, and also at the public talk a bit in the Q&A, are a series of things that are being done by the construction project to help prepare the community to answer scientific questions with this crazy data set before the data are available. And so at the very bottom of this timeline, you see DP acronym. That stands for Data Preview. And so Data Preview 0 has been going on with simulated data for some time. Data Preview 1 was initially planned to be using commissioning camera data. That plan has evolved, given slips in various aspects of the schedule, but there will continue to be data previews leading up to the first official data release, which is planned to be currently, I guess that's still at the end of calendar 2025. The first data before the formal cultivated data release is expected to be coming out to the community in early 2025. And along these lines, for folks who are familiar with the concept of a SciLog, it's a Research Corporation-sponsored series of 3 meetings that are implemented on a variety of cutting-edge science topics in all fields, not just astronomy. And so we're working with Research Corporation, who are getting ready to announce that there is going to be an early Science with LSST SciLog series, and the first one will be in late spring of 2024. So knowingly, write it down. There's dates that I forget what they are. They're in May. Knowingly before data will start flowing, and at least Heising Simons and Research Corporation are partnering on that workshop. And it comes with, they're super cool. So if you're grad students and then you eventually become faculty members, keep your eye out. Junior faculty who are doing awesome work in a field from diverse parts of any research enterprise are invited to come together and have a collaboration, discussion-based workshop on certain areas that are facilitated by senior individuals in the field. And the outcome intended for each one of the series of workshops is that invited participants are to come up with new ideas and write proposals real time right there, who will be eligible for seed funding. So it'll be $60,000 grants awarded per successful project at these SciLogs, which it's an increase of about 10K over the past ones. Okay, so that was a lot of context. What is LSST? What are the sorts of things that are going on? When might it happen? which gets me to the second half of my talk, which is the ecosystem. And even people who are part of the ecosystem, many of them aren't really familiar with the different parts of the ecosystem, even though they're participating as a part of it. So there's the Rubin project, which is what I've just described. There's the self-organized science collaborations, of which a number of you are active participants. And then there's LSST Corporation, which Joaquin introduced, and that's what my relatively new role is as the CEO of that organization. So first, I'm going to briefly define what are those different components, what do we focus on, and then I'm going to talk about really cool stuff that we're doing in the corporation, and again, highlighting areas that I've come to appreciate even more during my visit. I think that we resonate together with what's going on here and the sort of goals we're trying to accomplish at the corporation. So the project is, when I say project, it is literally the team, 150 people in multiple locations around the world, building and then will operate the 10-year Legacy Survey of Space and Time experiment. The science collaborations are a community of individuals, self-organized, about 2,500 around the world, who are excited about and preparing to do work with LSST. They started organizing around 2008, and that's where I entered the picture, and we collaborated, hundreds of us, on writing a science book that highlighted what could be done if this incredible machine was built. And that resulted ultimately in the successful funding request to build a machine. And we, the corporation, we're a coalition of about 30 member institutions that are all aligned on a shared set of values and goals for wanting to maximize the scientific and societal impact of the LSST data set and what might be some innovative, non-traditional ways to approach that. The funding for the Rubin project is really from the US government. We highlighted the $30 million of seed funding that Bill Gates and Charles Simonyi gave to kickstart it, but the vast majority, the $750 million scale for construction and similar for operations, is all Department of Energy and NSF money. There's some in-kind contributions that have been delivered by different institutes from around the world as well, but that core federal funding is the primary source. Now, the science collaborations, they don't have any specific thread of funding. The Dark Energy Science Collaboration does get some money from the Department of Energy to support their work because, unlike the way NSF is structured, the department is structured so that money to do the science comes along with the money to do the experiment. Same with NASA. Money to do the experiment or the mission comes along with money to do the science. That's not how National Science Foundation has worked, at least up until now. And we are privately funded completely through dues from member institutions, right, the coalition of 30 members, through foundations, through private donors, through corporations. And so even though I have a PhD astronomer, I spent years as a professor, I'm sort of a fundraiser in some sense now. And that sounds really kind of boring and yucky, right, if you're a scientist, but it's actually super cool and amazing because it means I get to talk to scientists, data scientists, software engineers, data visualization people, and bring a vision and cultivate that vision resonating off of people who have expertise, and we say, wow, maybe we can do that. How can we get that done together? And that's most of it. And then there's the icing on the top, is trying to figure out how can we fund these big, amazing, exciting ideas. And I spent the last, bunch of years of my life working firmly in the federally funded world, and I learned an enormous amount from that. But I also know that when I worked at a liberal arts college, I had money to buy my students pizza. I couldn't buy myself a box of tissues without using my own money when I worked in the federally funded world. So our ability to be flexible and agile is really fantastic. That comes along with some of the private funding. I can say I need an advisory committee in equity and inclusion, and I should be paying people, if I'm asking them to do work, to advise us on how to create equitable programs that are inclusive for the widest possible set of people. And I can do that. I couldn't do that when I worked for a national lab. I couldn't pay people to do work that we wanted them to do on advisory committees like this, which was a big challenge. Okay, so I put this slide up to remind you that the Rubin project isn't just building this enormous, fabulous telescope structure on the top of Cerro Pachon, and you see the size of those pickup trucks, and those are like, if you know Joaquin's pickup truck, it's like a regular little pickup truck. Like these are big ones that you like drive up and down mountains with dirt roads. And so like a person is like, if I'm next to that pickup truck, I'm like this big barely. This is an enormous structure. But the Rubin project is a system because one of the unique things about how this was approached when first pitched to the Department of Energy and the National Science Foundation was from the first launch point, they knew that community engagement and data management had to be integrated in, because otherwise, how would the scientific community be able to apply the data set to the big questions it was designed to answer? And so the team is developing a system to deliver high-level, calibrated data products to allow scientists to think of their investigations and to do compute next to where the data are. But you know, it's one thing to say those things, that this is incredibly important, but more than that will need to be done to feasibly take advantage of all the LSST dataset has to offer for the vast majority of individuals who, you know, may not be at the small number of very highly resourced, very highly specialized departments and institutions that are already familiar in the techniques and the tools that will be used. This slide also is to remind me to give proper acknowledgement and credit to the leaders of the different aspects of the Rubin project. Jelko Ivezic is now the construction director. He succeeded Steve Kahn, who was the director for the entire construction project up until Jelko. Victor Krabendam has been the project manager the entire time. He's an amazing project manager. And Bob Blum is the operations director right now. And here's a list of what I've already said verbally, the different components of this system that are being built and shared with the world. And you know, the alerts are world public, no proprietary period at all. The catalog data products are available to everyone in the US who wants to do a research science idea with it, anyone in Chile, and a large number, hundreds of individuals from other countries who have proposed how they could contribute to the project in some way, an in-kind contribution for their data rights. So it's a massively open data set, and all the software being developed is open source and on GitHub. The science collaborations connect with the project in a number of ways. So with one survey strategy and one instrument, the way the survey strategy is implemented can have substantial impact on how well you can answer certain science questions with the data set that comes out. How often do you go back to the same part of the sky? What is the time domain? What observing conditions do you put different filters on for the observations? And so the science collaborations were engaged in a multi-year process to write different metrics and run their science investigations through different simulated survey strategies to advise the project on what survey strategy would optimize the science that would come out of the survey data set. And so that's one example of how this distinct set of individuals, not under the project umbrella at all, were brought in to make sure the science possibilities were maximized. And so, you know, we as the corporation are working towards a future where the resources are available to realize the scientific potential of LSST. And so that's where one of my main hats as a fundraiser comes in. And we do this through programs, through advocacy for the community, through developing networks and partnerships to help make institutions able to accomplish what any single institution wouldn't necessarily be able to do by themselves, but to really coordinate and make those connections. You know, for example, I was having a conversation with somebody on the Viz team right before this, and I'm super excited about Viz. Which I know now is like somebody saying I'm super excited about astronomy, like it's really, but for example, make those connections between experts in innovative ways to get science out of the data through different types of visualization, and the scientists who have questions they think they might be able to answer, but they don't quite know how to scale it up to LSST size, or they don't know quite how, what's on the cutting edge of visualization that could be applicable. And we have some programs to address those opportunities in the area of software engineering right now. And so today, we have between $20 and $25 million worth of foundation funds from Brinson Foundation, Heising, Simons, Schmidt Futures, Templeton, Research Corporation, Gordon and Betty Moore Foundation to implement a number of programs. And this money is covering between now and 2026. And so the corporation itself is pushing more money than ever into the scientific community. This here is just a list. Of course, NCSA, UIUC have been a member for institution for a very long time. Super awesome that Joaquin came in October to our face-to-face board meeting and we could start to brainstorm and share ideas there. This shows that there's a lot of universities, there's some national labs, and there's a number of international universities and consortia who are coming together to participate in, what are the ways that we can be maximizing the scientific and societal impact? What are the programs that we're most passionate about? How can money be most effectively applied to our vision for Rubin LSST science? So how do we do this? There's 5 of us. There's me, all of me. There's all of an executive coordinator. There's all of a business and finance manager. We've got a quarter of a program manager and about a third of somebody directing link programs, which I'll end my talk with going into detail on. Sort of like three and a half people doing a really, really big set of things with a big scope. So how do we do this? Well, we have to collaborate and organize our member institutions and other departments to achieve these big things. We're not doing it in a vacuum. That is literally our role. We are a networking hub. We are an interface between what's going on in the project, the scientific community, and the resources, skills, and work being done at a number of institutions, and how the institutions and community can mutually benefit from those things. We coordinate approaches to philanthropists and foundations. I know individuals in the field, you might get a one-off grant here, there, $500,000 here, $1 million there from grants. The things that we're doing, because it's centralized and it's a hub, we're able to have more endurable impact of those dollars by centralizing the activities. Okay, I'll skip this. It's just about the $1 million+ a year going into the community. So what are the examples of these currently funded programs? Mainly I want you to all know about them because some of them may interest you to participate in directly. So there's been a number of different hands-on hackathons and workshops that have come with funding and travel support that have played key roles. One, the Cadence Hackathon was an example of where the science members of the science community came together to advise the project on how to best implement the survey to get the most science out of it. The Data to Software to Science meeting, which was just in 2022 at the Flatiron Institute, also brought together a diverse cross-section of individuals from the community to study how the Link Frameworks project, which I'll end the talk with, can best be fit to the most interesting and challenging questions. I think, did you participate in both of these, Gotham? Yeah. And to get the community input on that, and then also think about what are the barriers to inclusive participation and what are some recommendations there. And one cool thing that you can also do with the flexible funding is we have several senior social scientist advisors. One of them, Jana Diesner, is a faculty here in the Information Sciences Department, and be brought into, actually there's a lot of research. We've learned a lot about barriers to inclusive participation, barriers to multi-institutional work. And these are the sorts of questions that have been raised and recommendations already, so we can work together and move forward on progress together.
That's the first CAPS fellow right there as well.
Oh yeah, nice. And Meg and Peter and Matthew, okay. Another super popular program is sending students to present their LSST-related research to the annual Big Project and Community Workshop. And so I knew that this was a really successful program. I have a huge soft spot for students, especially undergrads, because of the time I spent at Haverford College and the deep, meaningful mentoring relationships I had the opportunity to be in there. And so we had a small-scale fundraising campaign at the end of December of last year, reached out to members of the board, members of the community at large, and said, hey, will you sponsor students to go present the results of their research? And so we raised enough money to send maybe 14, 15 students to the summer meeting this summer. There's not going to be in-person one the following summer. So if you want to go in person to PCW before data hits the ground, this is the summer. And I'm going to be talking to a corporation next week, maybe to get matching funds to bring even more students or some sort of additional support for students to work on LSST. And all these things I'm describing, like this is the part of fundraising that I don't prefer. We have to build in benefits for member institutions because we rely on that money to exist. A lot of people are like, oh, you've existed for 20 years. You're just a structure that exists. No, when you're soft money and you're a private nonprofit, you're not just a structure that exists. So you always have to build in benefits. It's like when NPR is like, oh, we're raising our money and you'll get a tote bag if you donate $50. It's like, no, you'll get student money and this and that. So member institutions and students at them receive priority for all these programs. And in fact, I think only member institutions will have the opportunity to apply for the student travel funds for at least a while. Something that's brand new, where we're partnering with the Heising-Simons Foundation and IceCube to implement a pilot program in providing childcare support for individuals who are impacted by those costs to attend major IceCube or LSST collaboration meetings in this year. So, right, the burden of different types of caregiving, whether it's elder care, child care, home care, other things, can disproportionately affect people at different points in their career. And some foundations, a lot of people are interested to understand this better. So we have money to offer basically grants. Well, we send you a check. You say, we need money for this. You provide a budget. We approve it. We send you cash. It helps you perhaps participate in person in a meeting. Very flexible, what you can ask for money for. And we also have resources to then assess the success of this program. Did it have impact? Could it have more impact if it was implemented differently or more broad to include elder care or other things? And so these sorts of short time scale, nimble projects are one fun thing that we get to do. So if you may be interested, keep your eye out. Rampel Gill, when she announces the PCW, she's going to announce this opportunity as well. And so then to end, I'm going to dive into LINC, the LSSTC Interdisciplinary Network for Collaboration and Computing. And it's really the programmatic arm of what LSSTC does, right? We bring in funds largely right now from foundations and develop these programs that benefit both individuals and the community-wide. And the key pillars are training, mentoring of future leaders, software and tools, right? The creation and sharing of different types of tools that will help scientists answer their scientific questions with LSST, and then community building, opening a discovery space to a more diverse and inclusive community. And this program was developed around the concept of there being hub institutions, each one that has a particular, specialty or interest that can really anchor some of the key activities going on and provide, again, mutual strength to the institution as well as the community at large. And so these are the 4 original hubs, and I'll highlight verbally the roles that each of them have in LINC right now. And something, of course, I'm interested in thinking when I'm here, what would it look like for University of Illinois / NCSA to be on this list? And I think there's a number of unique areas of expertise here that would fit very well within this ecosystem, providing something different than what these universities are providing right now. So the current funded projects within LINC are the Catalyst postdoc program, that's Templeton, Data Science Fellowship Program, that's Brinson and the Moore Foundation, as well as some NSF and corporation money. Catalyst is really geographically distributed. Data Science Fellowship Program run out of Northwestern, so that's one leadership role that Northwestern has had for some time in their Sierra group. The LINC Frameworks is based at Carnegie Mellon and at University of Washington right now, and I'm currently working on developing a concept for a community development arm. We build in the concept of community development to all our programs, but we don't yet have funding from a foundation that's really sharply focused on how to expand the community of potential users of LSST. And I have to say, is my Catalyst first? Yeah. And I have to say, it's really interesting. So the Catalyst Fellowship Postdoc Program was designed to be like an analog to a Hubble Fellowship-like program in terms of the amount of funding offered, the amount of research resources offered, the prestige that comes along with it. A couple of differences being, one, your proposal is judged not just by your scholarship and your proposed research area that relates to LSST, but it's also judged based on your proposed contribution to the community. And that can be through writing software. It can be through doing equity and inclusion activities. It can be through a wide variety of things, however you think of contributing to the community at large beyond just your own individual first author papers. And there's a highly structured mentoring process. If you're interested, you can read about it. The second astronomy cohort was just selected. I think we have 4 yeses now, but we don't have the press release out yet. But people have like tweeted what they're doing. It's really cool. We're also going to have 2 postdocs who are social scientists. And Jana Diesner, who's here, is the chair of that search committee process. They do things on a bit of a different time scale than us. So those postdocs haven't yet been selected. That's very exciting. So when you take a look at where the fellows want to go, you have to go to either a member institution or there's some expansion institutions. Small and under-resourced institutions are included. And the 4 hubs that I listed, Northwestern, Carnegie Mellon, University of Washington, University of Arizona, there's like a huge bias that the exciting, really well-informed, well-written, highly, like very connected with the LSST land are proposing to go to those institutions, in part because they're really doing visible, active work related to LSST. And so I see the opportunity of potentially, being whatever is called a link hub or visible in that ecosystem as a real attraction for potential prize postdocs in general, not just Catalyst fellows and graduate students, because it really goes beyond being a member institution saying like, no, we're contributing something unique that's really community building. And if you come here, there will be a support network and there will be multiple individuals who care about the kind of stuff that you're doing. So I think that's really interesting and cool. The Data Science Fellowship Program has been going on for quite some time. It's for graduate students who are interested to get trained in data science skills, statistical skills. How do you present the results of your research? Just how to be an awesome scientist in the era of big data. And this isn't just like going to a school. You're part of a cohort, and you go to multiple meetings per year for 3 years in a row. And so there's a dual component of getting the training in, but also building your network. And it's another way to expand the inclusion of people in the community from underserved, underrepresented populations in astronomy. And so the applications just went live for the next cohort for the Data Science Fellowship Program. It's on our website. I think there's even a link on our front page. It's extremely oversubscribed. Even if you're awesome, you might not get selected, but if you're at all interested, you absolutely should apply. It's a fabulous program. All expenses covered, all your trips, all going to all the schools and everything. And so here is the link frameworks, which is, again, funded by the Schmidt Foundation. And we've got a group of software engineers hired at each of University of Washington and Carnegie Mellon. And I went to an early link frameworks meeting in January, met one of your students there, and gosh, it was a fun group and a fun time. It's somebody who she worked for, I forget it was Amazon or Google, but big tech, and just cares passionately about coming and working for an astronomy project that cares a lot about making discovery accessible. And so it's a really interesting set of folks who are aligned in their ideals. So the big news with what's going on with frameworks right now is that there's incubators program happening. And I'll go back and I'll mention how many applications we got. So applications just closed this week for the first of a series of software incubators, where teams who have have, again, a scientific question they want to answer with LSST, but aren't quite sure how they can scale it up to the size of LSST, or aren't quite sure how they can actually do a calculation with data of the number of dimensions that are coming in, or how do you cross-match across catalogs in a certain way. Were invited to apply for an incubator where you'll get some amount of money, so $20,000, it's not very much money. The real value comes in, you get paired with data scientists and software engineers across the Link team, and it's not like CMU or UW, like everybody's working all together as one big team, and you get to partner and collaborate. It's not contract for work, it's like let's work together as a team and figure out how to answer this interesting scientific question with a large and complex data set, and while we're at it, let's apply it to public ZTF data or public DES data so that we can demonstrate progress in the short term. So we got 13 applications. For the first round, we're selecting 2. And I was surprised, I haven't looked at them yet, but this was like short time scale stuff. We really scrambled to get the call out at the time that we did for a lot of uninteresting reasons, but it shows how much of an appetite there is for this sort of initiative, partnering together people who bring different types of expertise and different types of resources to the table. Because, interdisciplinary, blah, 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 people have been talking about different, it's the age of interdisciplinarity, but like quite literally, this is an excellent example of an experiment that will demand interdisciplinarity to realize its scientific and societal goals. Okay, so the end. Points to end with are, look, we are a nonprofit, member-based institution. We want to revolutionize, vision of revolutionize how humanity understands the universe and transform norms of inclusive participation in scientific discovery. And like any vision, those are really strong statements, but you've got to have a North Star that you're driving to get you through all the challenges through the day-to-day, right? And think about, well, what are the steps I want to take to try to get there? We direct private philanthropy to programs that help drive us to that North Star, and just like the incubators are not a paid-for-service software engineers write me some code, we are partners with our member institutions where we work together to figure out what does that look like. How should we be pursuing and directing private philanthropy? And it's, it's hard because when I was a scientist, I didn't get any, I didn't know. People are like, well, why don't you just give that $10 million out as grants instead? I'm like, well, because that foundation doesn't want to give $10 million as grants instead. They have these other sorts of goals, so how can we align, right, the goals of foundations and the needs of scientists and all move forward together? And we're integrating the values of community building and inclusion from the beginning in the design of our programs. And it's really hard. And I'm sure we're not doing it right, but we're walking in the right direction. So in the end, this is the future that I have a vision to drive the corporation and all of you and everybody who wants to come along with it. And it's really hard, and it's really risky, and no one institution can do this alone, no one person can do it alone. And so it sounds like a platitude, but I mean it sincerely. Like, a lot of us who care about this have to come together and figure out. And it means, some stuff is pie in the sky, some stuff is meat and potatoes, and hopefully it'll work. Thank you all for your time.
Questions for Beth?
Michelle. Oh, should I call my own questions? Like, I kind of.
You can call me.
From your LSST corporation.
Oh, that's so nice. Look at that. Mic's everywhere.
Good job. Okay, the question I have is, originally we had a 2 data releases in 2025, wherever, when you're going to land. I wasn't sure in that first year. Are you guys still planning on those 2 data releases 6 months apart, or are you only doing 1 now?
Oh, yes, sorry. First I thought data was day, and I didn't. Yes, 2 data releases. The first one will be 6 months, then they go to annual after that. That's still the plan.
Awesome, cool.
Yeah, thank you, Michelle. Please.
The childcare thing you're doing with IceCube, so is that like on site at the meetings, or is this however you're going to work it out?
Really good question. So if you didn't hear in the room, how are we structuring this child care support program? And we are not actually providing child care. Let's say you would like to go to the meeting in Germany, but in order to do so, you need to fly a caregiver to come with you and your kid's out as well, you can ask for money for your kid's plane ticket, your caregiver's plane ticket, and the extra hotel room you need for your parent. And not a lot of people have taken advantage of it to that level, because I'm sure you feel like, oh, I couldn't possibly ask for like $5,000. It's like, you can. And so the sorts of requests we're getting so far are more modest things, like maybe local train tickets, or you can ask for extra childcare at home if you're attending the meeting virtually and maybe you need a nanny to come in because it's off hours, or you can ask for that sort of money. Yeah.
Actually, on that note, since you brought up the childcare support, one of the LSST Catalyst fellows who came here for Boom, Somaya took advantage of that offer, and we arranged childcare support for her of the highest quality, because I had Joaquin's child babysitter essentially also babysit for Somaya, and so that worked out perfectly, and thanks to LSSTC for the funding to make that feasible.
Oh, awesome.
So I do have a question though. So Link wasn't really on anybody's radar, and then sort of manifested suddenly as this massive thing, and it's still a little opaque to me how to sort of get involved in Link at an institutional level. What's the onboarding process essentially if NCSA were to do something?
So it's exactly this. It's coming to the meetings, asking questions, talking to Jenno, the director, talking to me, and figuring out how things can be mutually beneficial. There's no official onboarding process. The original 4 nodes were really set up to identify places with the history and the experience. So like CMU and UW had past relationships, for example, with Schmidt. And so it made a lot of sense. They had that past trust. CMU, computer software development, DRAC Institute, eScience. There was a huge amount of infrastructure that existed there, which made them good fits. Same with Northwestern, long history data science fellowship program. University of Arizona, original founding member across the street from Noir Lab. And so there's no sort of secrecy or magic, but yeah. And I think one thing, it's easy for me to come in because I know that there are probably different feelings going around with different members of like, well, why did they get to be hubs? And I think some of it is, I don't know if it's always been talked about in a way that really shines a light on. And I visited UW recently and really saw like, oh my gosh, like, yeah, there's a bunch of money coming from Schmidt to you, but you're giving an enormous amount of in-kind contributions to make this happen and leveraging years of experience in doing things like this in the past. And so it really is like institutions who can bring some of that to the table for the broad benefit of everybody. So they're the PIs at CMU and UW are not having easy lives right now.
Any other questions, Beth?
You probably know that last year the Willman Observatory was hit by a cyber attack.
Yes.
And that kind of thing would be quite devastating for a program like yours where you take data constantly.
Yeah.
So, sort of a large collaboration with lots of points of entry, how do you try to mitigate the risks there?
Absolutely. So I'll separate that into 2 components. The first is focusing on the actual, like the observatory, the data coming through. So Noir Lab as a whole, the national lab umbrella, is what Rubin will be operated through. And they have an entire cybersecurity team at the lab. And these sorts of considerations are central at all points. And of course, the federal agencies care a whole lot about the answer to that question. And then there's little old us. And when you're little old us, cybersecurity is a big concern, because I certainly don't have a cybersecurity expert on the team. Right now, it's relatively mundane things that we do, but our website is becoming an increasing hub of critical information. And so, one thing I'm doing is I'm partnering with the head of NCSA's communications, marketing, and design team in order to write a request for procurement of like a website overhaul. So of course, at the heart of that, I'll be thinking, who can we contract with and partner with that will provide sustainable confidence in their ability to support our cybersecurity needs? For us, it's largely through the web entry point. But I even concerned about like Zoom meetings and stuff like that. I mean, back at the lab when I worked for them, like there was some really nasty Zoom bombing of inappropriate content, and the more you're bringing in large swaths of people, the higher risk that becomes, and it's a major reputation damage, even if it's not hurting the data.
Let's thank Beth.
Thank you.